Okay. In last class, we have discussed about biomass conversion, thermoelectrical conversion, that is direct method, indirect method. Okay. Today we shall discuss about energy plantation and biomass gasification and also gasification process and principle of gasification and classification and chemical reaction now. Okay. First, energy plantation. I don't know how much you have celebrated the June 5th Environmental Day. Okay, growing of selected species of tree and plants on short rotation basis on waste or arable land for energy generation. They are saying that growing of selected species. Okay, not all the plants. Okay, only growing of selected species of trees and plants on a short rotation basis. Okay, rotation basis on waste land for energy generation point of view. And these are the four examples they have given: bubble grown even in wasteland, shisham high calorific value up to 4900 that is Kelvin per kg, and vilayati bubble root up to 50 meter, civis. Okay, these are the examples. It can be grown on wasteland. What about the energy plantation? That is for large production electrical power, the use of firewood. We use a firewood. Okay, we use a wood for energy generation as a, that is a coal. Here they are saying that for large production of electrical power, the use of firewood, that is coal, or the use of firewood as a fuel for the boilers of a conventional power plant is suggested. This approach is called energy plantation. What you mean by plantation? For large production electrical power, the use of firewood as a fuel for the boilers of a conventional power plant is suggested. This approach, what we suggested, that approach is called the energy plantation. Next is a biomass gasification. In this, it is a biomass gasification is nothing but a process of partial combustion. Okay, it is a process of partial combustion. And so in this, solid biomass is converted to combustible gas mixture. And incomplete combustion process. And next is a biomass plus A. Output what we get is carbon monoxide, carbon dioxide, methane, hydrogen, nitrogen, water vapor. Okay, the mixture of biomass plus A, what we get the output is carbon dioxide, carbon monoxide, CO is carbon monoxide, CO2 is carbon dioxide, CH4 is methane, and H2 is hydrogen, and N2 is nitrogen plus water vapor. These are the output what we get from the biomass gasification. The gas produced is a mixture of these all. Okay, that is carbon dioxide, carbon monoxide, methane, hydrogen, nitrogen. Okay, and the producer gas can be used into three terms. Okay, the producer gas can be used to run IC engines, nothing but internal combustion engines, that is both the combustion and spark ignition. Producer gas, what we get that biomass gasification, the gas we get that can be used to run internal combustion engines, and it can be used as a substitute for furnace oil, and it can be used to produce methanol economically. This is a biomass gasification. Okay, a gasification which is the incomplete combustion of carbonaceous fuels, and it can be represented that that is it can be we can show in the form of equation, that is a geometric equation. Okay, that equation biomass plus A output what we get, that equation we can say in that form. Okay, it can be represented in the equation form. You can observe this equation. Okay, biomass plus A. Okay, this is about the biomass gasification. It is a process of partial combustion and solid biomass is converted to combustible gas mixture, and it is incomplete combustion process. And if you remember this equation, that's enough. Okay, what is the input and what is the output we get, and that can be used to run the IC engines and substitute for furnace oil and to produce methanol economically. Next is a gasification process involved with biomass are, these are the process that is the drying of fuels, pyrolysis, combustion, cracking, reduction. Okay, these are the process or stages we can say. Gasification process involved with biomass are, first is the drying of fuels. Well, what does it do? Drying of fuels means process of drying biomass before it is fed into the gasifier. Okay, before we supply to the gasifier or that stage, faster we will dry the biomass. Okay, and next it is fed to the gasifier. Here, next it is a pyrolysis. What do you mean by pyrolysis? We have already discussed, okay, about pyrolysis. Breakdown of biomass into charcoal by applying heat in the absence of oxygen. In this process, pyrolysis stage, what does that happen means breakdown of biomass into a charcoal by applying heat in the absence of oxygen. And in the next stage, that is a combustion, all the heat required for gasification process are available from combustion. What we require heat for the gasification, that process is available from combustion. And next is the cracking. In this stage, breakdown of large complex molecules when heated. What does it happen means biomass, what we get, the waste is dried, and next it is sent to the pyrolysis. In that we convert into charcoal by applying heat in the absence of oxygen, and in the next combustion, gasification process is done, and next in the cracking, breakdown of large complex molecules when heated, and in the next reduction process, oxygen atoms are removed in this process from combustion products and returning them to combustible form again. This is the gasification process involved with the biomass. Next is a gasification process. In that also they have divided into low temperature gasification, high temperature gasification. Okay, low temperature gasification, the process temperature, it may be 750 to 1100 degrees Celsius. Okay, the process temperature is, I have already said, it is a low temperature gasification. You can observe with the high temperature, here 750 to 1100, here 1200 to 16 degrees Celsius. The gas produced has high level of hydrocarbons. Okay, here the gas produced has a high level of hydrocarbons, and it can be directly used for steam production and electricity generation, or it can be cleaned and used for internal combustion engines. The gas mixture composition depends on type of gasifiers. The gas mixture composition, it depends on type of gasifiers which we are using. Okay, we shall discuss about next in the next topics. Okay, that is a high temperature gasification carried out high temperature, that is 1200 to 1600 degrees Celsius, and the product gas is known as syngas. Okay, here the product gas is known as syngas. In the high temperature, remember, it has a high proportion of carbon monoxide and hydrogen which can be converted into biofuel compatibly for diesel engines. They are saying that what we get, high proportion of carbon monoxide and hydrogen we get in this high temperature gasification, and it can be converted into biofuel that can be used for diesel engines. Here, the average energy conversion efficiency of a wood gasifier is about 60 to 70%. How we can say the average energy conversion efficiency formula? That is a calorific value of a gas divided by kg of a fuel divided by whole divided by average calorific value of 1 kg of fuel. For example, if you take the 2.5 meter cube, that is 2.5 into 5.4 into 10 to the power of 6. This is megajoules per meter cube. So 2.5 into 5.4 into 10 to the power of 6, if you do, divided by 19.80 into 10 to the power of 6, you will get 68%. This is the calculation of average energy conversion efficiency. This is about the theory of gasification. First, we shall know about the principle of gasification. In all types of gasifiers, the carbon dioxide and water vapor are converted as much as possible to produce a carbon monoxide, hydrogen and methane, which are the main combustible components of producer gas. You can observe here what we get, that CO, carbon plus that is oxygen, what we get carbon dioxide here output, and here the output is H2O, water vapor. Okay, the carbon dioxide and water vapor are converted as much as possible to carbon monoxide, hydrogen and also methane, which are the main combustible components of producer gas. And what we get, this composition of biomass based producer gas, that this much percent we get that. Okay, CO, carbon monoxide 20 to 22%. Okay, H2, hydrogen 15 to 18%, methane 2 to 4%, carbon dioxide 9 to 11%, and nitrogen output what we get is 50 to 54% we get. You can observe here this gasification, it may be considered as a special case of pyrolysis. Okay, gasification is considered as a special case of pyrolysis, and it is a way destructive decomposition of biomass by heat is converted. Biomass plus heat. Okay, biomass plus heat, it is output what we get is charcoal, oil, tar and combustible gas. Okay, these are the outputs what we get from the biomass waste after the gasification. Okay, and they are saying that the product gas contains gases such as carbon monoxide, hydrogen, carbon dioxide, methane and also tar and dust. Okay, after gasification we get the output tar and dust and also CO, syngas, CO, H2, CO2, CH4, okay, etc. Next, here what they are saying is the gasifier design is to create conditions such that biomass is reduced to charcoal and charcoal is converted at suitable temperature to produce a carbon monoxide and hydrogen. First, biomass is reduced to charcoal and next the charcoal is converted, converted at suitable temperature to produce a carbon monoxide and also hydrogen. Next, the classification of gasifiers. Here two types, fixed bed gasifier, fluidized bed gasifier. In this type, biomass fuels move either counter current or concurrent to the flow of gasification medium, which is air, steam or oxygen. Here three types fixed bed gasifiers, three types. Okay, what are the three types you can observe here? Updraft, downdraft, cross draft gasifier. Okay, in detail we shall discuss in the next class. Okay, updraft and downdraft and cross draft we shall discuss in the next class. Now this is a second, second one is fluidized bed gasifiers. In fluidized bed gasifier, inert materials like sand, ash or charcoal is utilized to make bed and acts as a heat transfer medium. and it makes use of excellent mixing characteristics and high reaction rates of gas solid mixture. This is just a few details about classification of gasifier. In depth we shall discuss in further classes. Okay. This is the stage, that is a 5 process of gasification, or we can say that is the chemistry of reaction process in gasification. Okay, this is in a heading, it is in the textbook, that chemistry of reaction process in gasification, or we can state that is stage or 5 process of gasification. First process is drying, and second is pyrolysis and combustion, cracking and reduction. Okay, in drying of water with heat. Okay, biomass is first dried. In this case, biomass is dried. The moisture content of biomass is removed. Okay, what do you mean by drying? In heading only it is say the moisture content of biomass is removed totally. Okay, in drying. Some organic acids also come out during that drying process. These acids give rise to corrosion of gasifiers. Okay, what they are saying is during the drying process some acids will come out. Thus the acids will cause the corrosion of gasifiers. Okay. Next is a pyrolysis process. Here they are saying that heating without air to make charcoal. This is a pyrolysis zone. What we get the charcoal. Okay. Here 200 degrees Celsius. In first 100 to 15 degrees Celsius, and next is a 200 to 500 they have given. First at 200 degrees Celsius only water is driven off. Okay, only water is driven off, it is removed. And between 200 to 280 or 300, carbon dioxide, acetic acid and water are given off. Okay, that is removed. Carbon dioxide, acetic acid and water is water we get. Okay, are given off. That is reduced. And next is real pyrolysis process will take place between 280 to 500. At that situation only we get the output, that is tar and gases which contain the carbon dioxide. Okay, between 200 and 500, at that only we get the that is the large quantities of tar and gases containing carbon dioxide. Okay, and between 500 to 700 the gas production is small and contains hydrogen. And in next combustion process we get here the carbon. Okay, C plus CO carbon and oxygen. Okay, C plus O2 is mixed. Okay, C plus O2, carbon plus oxygen is mixed, and what we get the output is CO2, carbon dioxide. Okay, they are saying that carbon from the fuel combusts and forms carbon dioxide with the oxygen in the air by the reaction. Okay, in the combustion process, adding air to burn and crack tar gases. And next is the cracking. We have already discussed. Next, fifth, that is a reduction process. Here you can observe the equations what we have written here in the blocks. Okay, CO2 plus C. What do you mean by CO2? Carbon dioxide. What do you mean by C? Carbon. Okay, so carbon dioxide gas to react with carbon in the fuel and it forms a flammable carbon monoxide gas. Okay, flammable. Okay, it forms a flammable carbon monoxide gas. This reaction we call as endothermic reaction, and it occurs at a temperature is about 1000 degrees Celsius. Okay, when it exceeds 1000 degrees Celsius, this reaction will take place. Okay, you can observe in reduction what they are saying is converting charcoal to flammable gas. And the next reaction, if you observe in this block, H2O plus C. H2O is water. Okay, H2O is water vapor and carbon. C means carbon. What we get output? Hydrogen plus carbon monoxide. Okay, CO is carbon monoxide and H2 is hydrogen. What we get the output is carbon monoxide and also hydrogen. Okay, here the two reactions, that is first we mix with the carbon dioxide and also carbon, we get the output is carbon monoxide. If we react, if the hydrogen and also carbon, output is carbon monoxide plus hydrogen. Okay, and the next they have not, here it is not there, CO plus H2O, that is carbon monoxide plus hydrogen. If the carbon monoxide may react with water vapor and it will form a carbon dioxide and hydrogen, reverse process. Okay, carbon monoxide plus hydrogen. Okay, mixing the carbon monoxide may react with the water vapor, and what we get output is carbon dioxide plus hydrogen. This is about the 5 process of gasification. And here the conversion efficiency of a gasifier is defined as the ratio of the heat content in the producer gas to the heat content in the biomass supplied. Once again I repeat, conversion efficiency of the gasifier is defined as a ratio of heat content in the producer gas, that is output, heat content in the output, that is producer gas, divided by input, heat content in the biomass supplied. Okay, and they are saying it may be around 70%, the efficiency of gasification, conversion efficiency of a gasifier, it may be around 70%. Okay, in next class we shall discuss with the, I've already said, updraft gasifier and downdraft and the cross draft, and we shall discuss about the fluidized bed gasifier.